In this video, we will see deadlock prevention strategy for handling deadlock. We have 4 necessary conditions and solutions for each condition in detail. Necessary conditions for deadlock is mutual exclusion, hold and wait, no preemption and circular wait. Deadlock prevention will prevent deadlock by eliminating any one of the above 4 conditions. So we have to understand all these 4 conditions must occur in order to go for a situation deadlock. So if we eliminate at least one of these conditions, then we can prevent the deadlock. First condition, mutual exclusion condition. A resource can only be shared in a mutually exclusive manner, meaning a resource can be used by only one process at a time. To eliminate mutual exclusion is the solution for mutual exclusion condition. It is not possible to dissatisfy the mutual exclusion because some resources such as the tape drive and printer are inherently non-shareable. Mutual exclusion from the resource point of view is the fact that a resource can never be used by more than one process simultaneously, which is fair enough, but that is the main reason behind the deadlock. If a resource could have been used by more than one process at a time, then the process would have never been waiting for any resource. However, if we can able to violate resources behaving in the mutually exclusive manner, then the deadlock can be prevented. Spooling is the solution for mutual exclusion condition. For a device like printer, spooling can work. There is a memory associated with the printer which stores jobs from each of the processes into it. Later, printer collects all the jobs and print each one of them according to first come, first served manner. By using this mechanism, the process doesn't have to wait for the printer and it can continue whatever it was doing. Later, it collects the output when it is produced. But although spooling can be an effective approach to violate mutual exclusion, but it suffers from two kind of problems. This cannot be applied to every resources just like printer. After some point of time, there may arise a race condition between the processes to get space in that spool. We cannot force a resource to be used by more than one process at the same time, since it will not be fair enough and some serious problems may arise in the performance. Therefore, we cannot violate mutual exclusion for a process practically. Second condition, hold and wait. A process waits for some resources while holding another resource at the same time. The solution to hold and wait condition, allocate all required resources to the process before the start of its execution. This way, hold and wait condition is eliminated, but it will lead to low device utilization. For example, if a process requires printer at a later time and we have allocated printer before the start of its execution, printer will remain blocked till it has completed its execution. The process will make a new request for resources after releasing the current set of resources. This solution may lead to starvation. Third condition, no preemption condition. The process which once scheduled will be executed till the completion. No other process can be scheduled by the scheduler meanwhile. The solution to this condition, preempt resources from the process when resources required by other higher priority processes. Next condition, circular wait condition. All the processes must be waiting for the resources in a cyclic manner, so that the last process is waiting for the resource which is being held by the first process. The solution to this problem is each resource will be assigned with a numerical number. A process can request the resources in increasing or decreasing order of numbering. For example, if process 1 is allocated to resource 5. Now, next time, if process 1 asks for resource 4 or 3 is less than or 5, such request will not be granted. Only request for resources more than or 5 will be granted. This is the summary of the conditions, 4 necessary conditions and approach to solve the conditions. For mutual exclusion, we can implement pooling. For hold and wait, we can request for all the resources initially. For no preemption, we can snatch all the resources from that process. For circular wait, assign priority to each resources and order resources numerically. So in the next video, we will see deadlock avoidance algorithm using Banker's algorithm.